Alright. Sorry that my last video got cut off. This is a continuation of example 5 and 6. Example 5 was law of cosine. This is a practice question, so if you would like to do it, you are more than welcome to do it. Same kind of concept, except for you're just finding one missing side, which would be angle B, or choice B. Is the correct answer if you want to attempt it on your own. So in the example that we did together, you had to find all 3 missing angle measures. This is just asking you to find one of them. So moving on to example 6. Example 6 is law of cosine as well. Part of where you're going to know to use law of cosine versus law of sine is you're going to be given only one angle measure or no angle measures, which is when you're going to use law of cosine. So this one, you're only given one angle measure, or in the last example, in example 5, you were given 0 angle measures. In all of the law of sine questions that you did, you were given at least 2 angle measures and then a side length. So that's kind of where the difference comes in, is you're just given either no angles or maybe one angle, and have to find all of the other ones. So for this question, it tells you to solve triangle A, B, and C. So meaning what is not given to you is what you have to find. So you are not given angle B, angle C, and side A. Those are the 3 pieces that I need to find in order to answer this question. So for this question, part of why you can't use law of sine is I don't have a side length for A, so I don't really have a setup that I could do at all. Like, I would have multiple missing pieces, which isn't going to be helpful in setting that up. So I'm going to use law of cosine, and I'm going to use it a little bit differently this time. So in the last example, you didn't have any side lengths. You had, or you didn't have any angle measures, sorry. You just were given 3 side lengths. So I had to automatically solve for one of my missing angle measures. In this one, I'm given an angle measure to at least start with, but I'm not given one of the sides. So the other way that I can use the law of cosine, and I'm going to specifically use the one that says A is equal to, or A squared is equal to, the reason I'm using this one is I know angle measure A, which is this, and I don't know side A, which is this, which would be what I'm solving for. So you can also use law of cosine to find a missing side length if you know one angle measure and then you know the other 2 sides, which is kind of where it's a benefit to be able to use for that as well. You could also use, again, any of the other law of cosine formulas. So I could plug in, actually you couldn't, because you would need to know all 3 side lengths, and you don't know all 3 side lengths. So ignore me on that. So you would have to use this to kind of start with. So plugging in what you know, I don't know A, that's what I'm trying to find. My B value, so again, remember, your angle measure and side lengths are across from each other. So your B value would be 12 squared. Your C value is 14. My B value again is 12. My C value is 14. Then this is cosine of angle measure A. Angle measure A is given to you, so 39.4. For this question, you are more than welcome to do this all in different parts. However, this is all one big thing. You are more than welcome to plug that entire chunk into your calculator at one time. If you do that, you would get A squared is equal to 80.36. So whenever you get this and you solve that, that would kind of be your next step. However, your next thing that you would go about doing is, I have a squared is equal to that. I need an a by itself. So in order to get an a by itself, I would have to take the square root of both sides. So whenever I do that, I end up with 8.96. It tells you to round to the nearest tenth. For this question, your 6 is going to make your 9 round up, which is ultimately going to make your side length just be a, or be 9. Sorry. So your side length of a is now 9. From here, this is again where you can use law of cosine, law of sine. So I can use law of sine now to help set this up because I have angle A and side A. So if I'm setting up law of sine, I would have sine 39.4 over 9 is all of my A information that I have. Again, it doesn't matter which one you solve next. You can do sine of B or sine of C and find whichever angle measure. When I did this, I did sine of B. So I don't know angle B, but I know the side length of B. So again, cross multiplying. So I would have 12 sine 39.4 is equal to 9 sine B. I'm going to divide by 9 on both sides, and then I'm going to divide by sine on both sides. So when I solve this, it would really be sine negative 1, 12 sine 39.4 over 9. This whole chunk I'm going to plug in my calculator and solve for B. It tells you to round to the nearest degree for your angle measures, so you're just going to round to the nearest whole number. So whenever I do that, I would end up with 57.8, which would really round to 58. So I then found this angle measure is 58 degrees. From here, the last thing I need to find is angle measure C. So finding your last angle measure should always be the easiest. I know a triangle adds to 180, so I would do 180 minus the 58 that I just found, and then minus the 39.4, which was given to me. Whenever I do that, I would get 82.6. However, 82.6 would round up to 83 as my degree measure. So similar to last example, as far as like starting with a law of cosine and then moving to a law of sine and then kind of really just filling in your missing angle measure, looks a little bit different because I didn't know one of the side lengths versus I didn't know an angle measure. In my opinion, law of cosine is a little bit easier when you have one of your angle measures. There's less work to do for it. I really just get to plug the whole thing into my calculator and solve for that one missing piece versus do a bunch of steps, have to subtract something over, then divide. Again, really just plugging into a formula. So, moving on to example 7. So example 7 is what is called Herons Formula. This formula will be something that's on the board. There are two things to kind of note with this. There are actually two formulas here, meaning this is the actual area formula. Within that, there is S. There's also a separate formula for S in order to find that to be able to actually plug it into Herons Formula. So both of those will be present on the board. Whenever you're taking a quiz or a test, you need the S formula to be able to use the other one. So this is finding area of a triangle. I can't just use 1/2 base times height like you're used to with finding area, because these are not just a right triangle anymore, it's other types of triangles. So this is one of the ways that I can use side lengths specifically to find an area of a triangle, because I'm not given height, which is what I would need if I'm using 1/2 base times height. I don't know my height. There's not an easy way to find that, so this is kind of a formula to help you find the area without having to do a bunch of extra work. So the way these questions are going to be worded are going to ask you to find the area to the nearest tenth, and it's going to give you a triangle with 3 side lengths. So to just have both of these formulas here as we are working, and then S is equal to 1/2 A plus B plus C. So S is really just finding the average of all of the sides added together of your triangle, if that makes sense. So the first thing that I need to find is S in order to actually be able to plug into the area. So to find S, I would have 1/2 times A, which is 47, plus B, which is 53, plus C, which is 44. So again, something you can just plug into your calculator as one whole thing, or you can do it in multiple steps. If you're going to do it in multiple steps, I would add all 3 of those together first. So whenever you add 47 plus 53 plus 44, you would get 144. Then when I multiply that by 1/2 or divide by 2, whichever way you want to think about it, I would get that S is equal to 72. So that's going to now help me plug into this actual formula, which I need. So plugging into that, I have the square root of S, which is 72, then S minus A, which would be 72 minus 47. So remember, your side lengths are across from each other whenever you are doing these, which is how I know that 47 is A. Then I would have S minus B, so 72 again, minus my B value is 53, and then S minus C, which would be 72 minus 44. I would, on this part, instead of plugging that whole thing in as like a square root, I would do the part that is under the square root first. So like do 72 times 72 minus 47. You could even just do like these individual pieces and get those 3 numbers for subtraction and then multiply the 4 of them together. I wouldn't try to plug all of that in under the square root at once. You can, but it's going to cause more room for error if you don't plug something in correctly. Like if you accidentally leave one outside of the radical versus put all 3 of them under the radical. Just kind of easier to go about that way. So when I did it, I just plugged in the 72 times 72 minus 47 times 72 minus 53 and then 72 minus 44. If you're going to plug it in that way, make sure you put parentheses because that part is important. So you would end up, once you multiply all that together with this number, then you're going to take the square root. Whenever you take the square root, you would end up with an area of 978.6. So that is how you plug into that and then solve your answer. Example 7 is another example of that with Herons Formula. If you want to attempt it on your own, you're more than welcome to. I'm not going to work it out. If you want to work it out, your answer would be C. Then looking at example 8, Example 8 gets into area of a triangle as well, specifically when you are given a side angle side. So the difference between example 7 and example 8 is example 7, you were just given all side lengths and needed to find the area. This, you're now given 2 side lengths and an angle measure in order to find the area. So again, all 3 of these formulas will be something that are on the board that you'll be able to look at. They're all very similar to each other. So the one that you're going to use is dependent upon which angle measure you are given. So like if you're given angle A, you're going to use the first one. If you're given angle B, you're going to use the second one. If you're given angle C, you're going to use the third one. Not super confusing on which one you're going to use when. So example 8 is your last example in chapter 4, lesson 7. So you can see, looking at your triangle, I'm given angle A, I know side length C, and I know side length B. So this automatically tells me that I am using the formula that says 1/2 BC, so side length B, side length C, I'm given those two, and then sine angle measure A, which is the angle measure that I'm given. So I'm plugging in to what I know and then solving. So I would have area equals 1/2. The side length of B is 39. Your side length of C is 52. Then I would have sine of my angle measure A, which is 25.89. You are plugging that whole thing into your calculator and then solving. So whenever you do that, you would get 42.8. Because we are talking about area and I didn't do this on the last one, it would technically be inches because it actually gave you a measurement in this one. So it would be inches squared. And that is your answer for that. So that is finishing up law of cosine, Herons formula, which is finding area, and then this is also finding area. Look a little bit different. It will tell you on a quiz or a test that you are to use Herons formula or you're to use area of a triangle given SAS. That way there's some differentiation. Again, Herons is if you're given 3 side lengths and no angles. This one is if you're given an angle and then 2 side lengths. So that is it for chapter 4.